Hey guys, this is the AddiSteel team from Youngstown State University. Today we present to you the additive manufacturing process for American Makes. We present to you guys our multi-tool. I'm an industrial systems engineer. My name is Ayman Kutub.
I'm Negan Amirzadeh. I'm a senior in chemical engineering program.
I'm James Souls. I'm also a senior in the industrial engineering program at Youngstown State University.
I'm Stephen Sly. I'm a mechanical engineering major at Youngstown State.
A little bit what we're going to talk about in today's video. We're going to talk about how we designed the process, a little bit about how we were printing that product, and also how we did the corrosion testing on the items to go alongside everyday use.
For our design, we decided to create the basis of the multi-tool off of a locking plier frame. As shown, we have a flathead and Phillips screwdriver head, as well as a 1/4-inch socket drive that all fold out from the smaller handle and are held in place by a swiveling locking mechanism when not in use. On the larger handle, we included a knife that folds out, a glass breaker on the bottom of the adjustable stop for the locking pliers, a hammer, and a multi-use prying hook. The wire cutters were included within the plier jaws. For the plier locking mechanism, our locking bar tapers to have a larger bottom, which prevents it from slipping. A quick release handle is also included on the bottom of the small handle for easy grip release.
Guys, so during our iteration process, we decided to print on the Anycubic Cobra 2 using PLA+. During this process, we were looking more towards ergonomics and design processing, so we're not just printing every time on 316 stainless steel. You can see here's one of our iterations.
After we completed our prototype printing with PLA plastic, we decided it was time to move toward 316 stainless steel. And we did this by using an exact metal machine, which actually uses a stainless steel powder and zaps it with a laser in order to build up layers for a tool or a different kind of part. In this process, we actually finished our final design. Here you can see this opens up and we have some extra tools in here that can be used for different tasks. But overall, it took us about two full iterations on the laser powder bed fusion printing process in order to come up with our final design.
When we choose a multi-tool, one of the most important things for us, especially in industry, is to make sure that tool doesn't corrode over time. Therefore, we design a corrosion test and we use 2 molar HCl over the period of 4 to 5 days to make sure our multi-tool would not corrode that fast and it would be able to be used in different industries. So our test was focused on comparing the mass percentage loss and also mass loss over time, and we concluded that fortunately we will not have corrosion and that fast, and this multi-tool will be able to be used in different industries and as long as it's not exposed to heavy-duty materials.
We did face some challenges and difficulties along the way, including manufacturing time, design changes, and the assembly process. However, we are excited to present our final product of the 316 stainless steel multi-tool from the Youngstown State Additive and Manufacturing team. Thank you for your time and consideration.